Welcome to clickmyproject.com. Our project title: Maximizing Data Collection Throughput on a Path in Energy Harvesting Sensor Networks using a mobile sync. Let's see the abstract. In general, in energy harvesting wireless sensor network, maximizing the data collection throughput is one of the most challenging issues. Hence, in this project, we consider the problem of data collection on a pre-specified path using a mobile sync which has a fixed mobility pattern. As a generalization of the previous work, we propose an optimization model for the problem which incorporates the effective and the heterogeneous duration of the sensor nodes transmission in each time slot. To improve the network throughput, a simple condition is proposed, which determines the maximum number of available time slots to each sensor node. Accordingly, the proposed condition specifies the constant velocity for the mobile sync. This problem under the proposed condition is proved, and a centralized algorithm with less complexity is designed to handle the problem. Its complexity is in polynomial order and is easily scalable to the network with large number of sensor nodes. Furthermore, we address the effect of increasing time slot period on the total amount of collected data which has not been yet exploited. Through the extensive simulations on different set of deployed nodes, we observe that the proposed algorithm significantly increases the network throughput when the traveled distance by sync per time slot is reduced to the adjusted point. Now see the flow of our process. First, the network is formed, which consists of the number of sensor nodes and the mobile sync. All these nodes and the sync have included the energy model. After that, the data collection is processed when the sensor nodes have the sensed information. This data collection process is done by traveling the mobile sync in a path. This collection is processed by the time slot mechanism. In this mechanism, if the sensors are registered to the mobile sync means it transfers data to the sync node. Also, the updated energy is processed for all the sensor nodes. If it not registered means the decision phase is processed, that is, the sensor node is registered or not is processed, and it allocates the time for the transmission, and again the conditions are verified for the communication. Finally, the performance is analyzed for the proposed system, which is compared with the existing system. Now see the running process. First, open the terminal window, then go to the directory where we have the code, then type witness space file name.tcl and press enter. The nodes are created in the network. At each and every simulation time, the positions and the energy are updated for efficient data collection process. After that, this is the network animated window. Here only we see the simulation results. To see the output, maximize the window. These are the number of nodes created in the network like a routing path implementation. To run simulation, click the play button. This is the base station and this is the mobile collector which going to collect the data from the sensor nodes. We can speed up the simulation process using this button. This is the simulation time that runs here. Now the mobile collector moves in the network. Now here a sensor node generates data and it transfers to this mobile sync. Like this, each and every sensor that have generated data is specified in a different color. It transfers the data that it have to the mobile sync node. This mobile sync transfers the data which they collected finally to the destination node. Can speed up the simulation process. Here the sensor nodes collects the data. Now it finally transfers all the data to the destination base station. To see the graph results, back to the terminal window and type xgraph space graph name dot xj. This is the delay graph. Here the simulation times are varied and the delay is calculated for the packets. And to see another graph, type xgraph space file name dot xj. This is the energy consumption graph for all the nodes in the network for each and every simulation time. So this is the overall running process of our simulation. Thanks for listening.